For the next 5 videos, we are to solve the translation of a certain point along given lines here. But of course, we will have the same lines. We'll just be changing the points on the next 5 videos. So what we will be doing here is to first plot this on our Cartesian plane using the intercepts, and the same graph and the intercepts will be used in determining later on a translation in the next 5 videos. So if you're going to look at the next 4 videos, please of course return to this if you are not yet convinced with how it is plotted. So first and foremost, we know that the translation, or to solve for a translation, we have two different methods. We'll have the double reflection or the formula for the translation using the foot of perpendicular. In this case, we'll be using the formula for the foot. Okay, so please bear with me as we are going to discuss it thoroughly here. But of course, let's start by plotting our point x on our Cartesian plane. It's actually at 0 and 4. So 0 and then 4, you have 1, 2, 3, 4, considering that each grid here is actually 4. This is our x. Okay, this is actually at 0 and 4. Now, it's not enough for this graph for us to say that we are going to solve in this manner. This notation means the the translation of x along line L. But we are not sure that it should be on along line L. Meaning, we are going to take the reflection, if we're talking about reflection along line L, and then such reflection will be reflected on line M to get the translation. Because it might be in this manner as well. What if we are taking the translation along line M? That is why we need to graph it first, because we need to identify which line is closest to our point x. And if that line, say for example, line L is closest to line x, we'll be using that. If it's closer to line M, we'll be using this. Yes, we will have two different forms or scenarios if we cannot actually pick the right line. That is why, let's plot this first. Okay? So when plotting that, of course, you could always use the intercepts. So for line L, which is x minus 2y equal to 4, so we use here the x-intercept. So we let y be equal to 0. So you have x minus 0 is 4, x is 4. So your x-intercept is at 4 and 0. Now, for our y-intercept, we let x be equal to 0. So you have 0 minus 2y is 4, minus 2y is 4, so y is negative 2. So the y-intercept is at 0 and negative 2. Let's continue first for our m, and we will be plotting them later. So if x minus 2y is equal to negative 4. It's also good to note that our slopes for these two are actually the same. Hence, we will really have a parallel line, our set of parallel lines. Okay? So, talking about set of parallel lines, we also know, as needed later on in the process, the unit normal vector, we also have the same unit normal vector. So, by the way, let's continue here. So, let y be equal to 0 for our x-intercept. So, you have here x minus 0 is negative 4. So, x is negative 4. Our the x-intercept for line M is negative 4 and 0. For our y-intercept, so let x be equal to 0. 0 minus 2y is equal to negative 4. Minus 2y is negative 4. Y is positive 2. Hence, it's at 0 and 2. Okay? So, let's plot them here. Let's start with line L. Our line L, our x-intercept is 4, 0. And then later on, 0, negative 2. So, using these 2 points and connecting them with a certain line, hopefully I could connect them in just one attempt. I can't. Let me do it again. Sorry. I'm just hoping that I could really connect them just like that. Using arrowheads, this corresponds to our line L. Okay? Now, for our line M, its points are at negative 4 and 0. So, 1, 2, 3, 4. This is our x-intercept. And then 0 and 2. This one here. So, if I may, let me again connect this with a line. Hopefully, I could graph it well. No, I can't. Let me try to do it again by connecting them. Alright, so just like that. I can even draw, by the way, a scribble for it to be aligned. So you have here, this is our line M. As you can see, our point X is somewhere here. It's closer to M. So it's incorrect for us to use this notation, okay? Because this means translation of X along line M. what would happen here is, if this would be guaranteed, that if we're talking about the translation against line M, so we're going to reflect it at line M here, and then later on reflect it at line M, which is a little bit difficult. So it has a different meaning if we're going to stick with what is the closest line. So it's closer to our line M, okay? So it's closer to our line M. That would mean the translation format that we are going to take here is this form. The translation, of our x along M. Okay? So if we're taking about, or if you're going to use the double reflection, reflect it at line M first, and then reflect it at line L to get the translation. But then again, our process here would use the foot. So we're going to use this formula. You will have the translation. Again, this is the right form. Is x plus twice p minus q. I'm going to use this because it's simpler for me. I just need to use the unit normal vector once, okay, rather than using them twice for double reflection. Speaking of that, we actually need here the unit normal vector because our point P, okay, is actually the foot of perpendicular, okay, in in second line. So in the end L, using Q in M. Take note of the notations being changed because M is the closer line to your X. Okay? So to get the foot, we really need the idea of the unit normal vector. So we're going to use here the unit normal vector as well. And we're going to copy this as mentioned in the next few videos. We have 4. So we have here the normal vector is indicated by this one here and that. So our A is actually equal to 1 and our B is negative 2. The length of our normal vector is identified as the square root of the sum of the squares, which will give us the square root of 1 plus 4 square root of 5. Okay? So that would be our length. So for our unit normal vector, let me move this here. Right? Our unit normal vector indicated as the ratio of your normal vector in parenthesis form over your length, or it could be 1 over square root of 5 and negative 2 over square root of 5. Okay? This is the unit normal vector. Even if we're going to use the reflection, you will still be using this because the same unit normal vector would be used for parallel lines. And by the way, we'll be using it once here because I'm using the second formula. So with this, let's try to identify first our point P. Take note that we need to really choose the correct points. Take note that Q should be in M. Okay? Our X is already identified here, 0 and 4. Our Q must be on M. Now, M is here. You pick your points. I would like to choose, again, the x-intercept. You can even choose the y-intercept if you want to, but it would be, to be consistent with what we did previously, let me use the x-intercept. So our Q is at negative 4 and 0. Now, take note, with this, we can identify our P, which is a foot of the perpendicular. In short, we have here our Q as at negative 4. This is our Q, right? The point P is somewhere here in the third quadrant. We would be expecting the foot to be of negative components. And let's try to do that here. But of course, the formula for our P, which is identified the foot, is given as x minus P, and the unit normal vector identified here. Now, before we continue, take note we are now using the x's, p's. So allow me to revise this formula so that the x will be used here would not be this x nor the p. Since this is just for the foot using this perspective, so our x would be our Q, the reference for our foot, Q, minus our P is the x-intercept, okay, of our line L, the second line, okay? It's not P because we'll be using P later on as the foot, right? This would be same unit normal vector and unit normal vector here. So with this formula, it's easier for us to solve for the foot, okay? So our Q is negative 4 and 0 minus, you have your negative 4, 0, and the intercept of L, the second line. You can use the x-intercept Again, to be consistent, we have 4 and 0. And we're doing this because when you look at this, when you combine that, the second component should be 0, and it's easier for us to even take the inner product against the unit normal vector as we have a 0 component. Okay? So please bear with me. Allow me to do this step by step. If you would like to use a double reflection, you may. I'm just more comfortable and more confident with this process. Negative 4 is 0 minus. The result for that is negative 4 minus 4. We have negative 8. And again, 0 for the second component. To be multiplied, or I mean inner product of that with this unit normal vector. And again, another unit normal vector here outside. So we will have here negative 4 and 0. The inner product of that, negative 8 times this, is negative 8 over, sorry, it should be, it would now be a scalar. So negative 8 over square root of 5 plus, when you do this, that's actually 0. So we don't need to write that here, nor place all of this. So you have that times your unit normal vector, negative 2 over square root of 5. Don't worry about the radical expressions, because here, when you multiply the scalar, it will become negative 8 fifths. And then you will have here positive 16 fifths. So your foot is actually the result of this. You have negative 4 plus 8 fifths and 0 minus 16 fifths, which gives us a result. You can use your calculators here. Negative 4 plus, you have 8 fifths. You'll have, in fraction form, negative 12 fifths. And then you have your negative 16 fifths. As you can see, our foot is really at the third quadrant, both negative. So it comprises, or it checks this being the foot. But that is just the foot. So allow us to finish this by solving for the translation. Again, in do this form, the closer line is M. So you need to identify that carefully. X plus twice P minus Q. Our Q is of course identified here. Our X is now this. And our P is the foot. This is also equal to your P. So our result is X being 0 and 4. 0, 4. Then plus twice. Your P is negative 12 fifths. Negative 16 fifths. That would be subtracted with your Q, which is negative 4 and 0. Okay? So you have here 0, 4. I'm just going to try fitting this in the space. So you have twice. So you have negative 12 fifths plus 4. Okay? So you have 12 fifths plus 4. You will have actually a result which is equal to positive 8 fifths. And then negative 16 fifths minus 0 is of course negative 16 fifths here as well. You have 0 and 4 plus twice that. You have 16 fifths. Then negative 32 fifths. So your translation of X along line M is 16 fifths. And then 4 minus 32 fifths is actually 20 fifths minus 32 fifths, negative 12 fifths. This is the translation of X along line M. And it's in the fourth quadrant. Let me check here. So this is our X, right? This was our X. By double reflection, you have it here. And of course, you will have it there. So basically, it's in the fourth quadrant. Specifically, this space here, you have 16 fifths is 5.2, if I'm correct. Sorry, 3.2. So 3.2 and then negative 2.4 somewhere here. This is the translation of your, sorry, it should be this one, of your X along line M. So you have here 16 fifths and negative 12 fifths. So we used here this formula. And of course, if you would like to verify this using double reflection, you may. So we'll have 4 more examples using these 2 lines. So we will have different points to be translated. So allow me to copy all the rest of the process here together with the graph, so that later on we can just simply jump to the process and intended for the foot and later on for the translation. Thank you very much for watching.